Okay, Bismillah ar-Rahman ar-Rahim. Inshallah, in this video, we'll do sigma notation. We'll talk about only sigma notation, and then I will do the area. Because we need the sigma notation to do the area. So just I will deal with the sigma notation, and then to go back to this lower sum and upper sum and the areas. Okay, what do you mean by sigma notation? This is the sigma notation. This is the sigma notation. So I need I equal to a value, starting point, and this is the end point. And then we put the argument there. So summation of AI from where I goes from M to N. So it means what? It means I have starting with AM plus 1 until I reach AN. Until I reach AN. That's the meaning of that. Just the sum of these values. If it is I equal 1 to N, that will be easier. So it will be A1 starting with 1 up to N. A1, A2, A3 up to N. The I called the index of summation. AI they call the ith term. And they have upper and lower bounds, which is the upper bound is this one, and lower bound is this one. That's the meaning of sigma notation. As I said here, if I equal M to N, then I have, and I have AM, AN plus 1, AN plus 2, blah, blah, blah. Then I have AM up to AN, okay? Any easy examples? For example, summation I square. It means what? I will put I equal 1, that will be 1 square. Then the next one, I will be 2. Then I have plus 2 square. Plus, next one will be I equal 3. That will be 3 square. Next one, I equal 4, which is the last one, plus 4 square. And then sum them. I have 1 plus 4 plus 9 plus 16. That will be what? 30. Huh? 20 plus 10, 30. Another one, summation of I, where I equal 3 to N. That means 3. Then the next one, I will be 4 plus 5 plus N. Since it's up to N, I cannot find the value. You can do it in the formulas, but later we'll do that. Now, I starting from 0 up to 5. So I have 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 when I equal 2, when J, this one J, okay, who cares? J equal 2 plus 2 to the power 3 plus 2 to the power 4 plus 2 to the power 5. That will be what? 1 plus 2 plus 4 plus 8 plus 16 plus 2 to the power 5, which is 32. That give me what? This is 40. This is 60, 63. That will be 63. Correct. Yeah, 40, 20, 63. Summation 1 to K. 1 over K. So in K equal 1, I have 1 over 1. So it's 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. And when I will stop, 1 over n. Now, summation I equal 1 to 3 of the I term is complicated a little bit. So just substitute. I equal 1. I have 1 minus 1 over 1 square plus 3. I equal 2. That will be 2 minus 1 over 2 square plus 3. Equal 3, which is the last one. That will be 3 minus 1 over 2 cubed plus 3. This is 0, halas. So this is 0 plus. I have 1 over 2 square, 4 plus 3, 7. Plus 2 over 2 cube is what? 8. Plus 3, 11. So that gives me what? 77. I have 11 plus 14. So that will be 25 over 77. Okay, this one. When I equal 1, it's 2. When I equal 2, because there is no I, huh? It will be does he want me to do the expanded form? Okay, so 1 cube root of I, that will be, I have summation, I equal 1 to 5, cube root of I equal 1, that will be cube root of 1, which is cube root of 1, plus cube root of 2, plus cube root of 3, plus cube root of 4, plus cube root of 5. And that will be 1. This is 2, this is 1, so that's 3 plus square root of 2, square root of 3, square root of 5. 2. Summation I equal 4 to 6. I'm starting to 4 up to 6 of this 3 to the power I. So I have 3 to the power 4. Next one, I will be 5. That will be 3 to the power 5. Then I equal 6, 3 to the power 6. You can do the calculation. 5, this is 3. 5, that will be what? Summation, k equals 0 to 4. 2k minus 1 over 2k plus 1. When k equals 0, I have what? Minus 1 over 1. When k equal 1, 2 minus 1, that will be 1 over 3. When k equal 2, that will be 3 over 5. When k equal 3, that will be 6 minus 1, 5 over 7. When k equal 4, that will be the last one. I have 7 over 9. Yeah, you can simplify it. I will leave it for you to simplify, but this is the idea. 7, this one. I to the power 10. I equal 1, that's 1 to the power 10, 2 to the power 10, plus 3 to the power 10, plus, n to the power 10. 9, last one. Summation j equals 0 to n minus 1, minus 1 to the power j. When j equals 0, minus 1 to the power 0, that is 1. Let me write it here. That will be 1. J equal 1, that will be minus 1, plus 1, minus 1, until I reach what? Yeah. Minus 1 to the power n minus 2, minus 1 to the power n minus. Yeah, these cancel, but I don't know where I will stop. It depends on n. If n is even, then it means the last answer is, it will be 0. Huh? If n is even, notice, if n is even, it means to do what? N is even, that this will be cancelled, until I reach, let me take one more. If n is even, that will be minus 1, plus 1, and then minus 1. Okay. Let's say, notice what? I'm starting with 1, 1 minus 1 plus 1 minus 1, so that gives me 0. If n is odd, where I will stop? If n is odd, in a plus this coming like this, 1 minus 1 plus blah blah blah. Okay, so this is cancelled. For sure I have 1 here. Okay, so it will be 0. If n is odd, my last one is odd, so n is odd, that will be, so the answer will be 1 minus 1 plus blah blah blah. When it comes here, n is odd, odd minus odd is odd, that will be minus 1, and this is odd. No, odd minus odd, it will be positive, Yeah, odd minus odd will be even. So that will be plus 1. Then odd minus 2, that will be odd minus 1. Odd minus 1, that will be positive. So it has plus 1. So the answer is 1 if n is odd. The answer is 1. If n is even, the answer is 0. You can check, take a value. For example, n equal, make it 3, easy. What you will get? I have summation, j equals 0 to 2 of minus 1 to the power of j. That will be what? 1 when j equals 0, when j equal 1, I have minus 1. When j equal 2, I have plus 1. So it's 1. If n equal 4, for example, just to be sure, 0 to 3, huh? It will be up to I4 minus 1, which is 3. The same thing. So it will be 1 minus 1 plus 1, 3, it will be minus 1. So the answer is 0. Okay, so sometimes you need to manipulate the calculation. Now this is the different things. You have the sum. You want to write it as a summation. Okay, so let me do 11. I think I put the space. Yes, let me do 11. 1 plus 2 plus 3 plus 10. How to write it as summation? This is will be equal summation of I starting from 1 up to 10. So I have I equal 1, it's 1. I equal 2, it's 2. So I have this. So this is I want to write the sum in sigma notation. Okay, 13. I have 1 over 2 plus 2 over 3 plus 3 over 4 plus 4 over 5 plus 19 over 20. Okay, that will be what? Summation. Okay. I want to start from 1. K equal 1. So I have what? I have in the numerator, I think up to 19, huh? I have k, and that will be k plus 1. So in k equal 1, I have 1 over 2, which is this. In k equal 2, I have 2 over 3, which is this. In k equal 3, it will be 3 over 4, which is this. And I will stop. The last one will be 19 over 20, which is this one. So that will be the summation. 15. 2 plus 4 plus 6 plus 8 plus 2n. I want to write the summation. So I can make it what? Yeah, very easy. I can take 1, 2 as a common factor. So I have this. So that will be 2 times summation I equal 1 to n of I. 1 plus 2 plus 3 plus n times 2, where 2 is outside. 2 does not depend on n. Okay, 17. You have 1 plus 2 plus 4 plus 8 plus 16 plus 32. I'm going to write it as power. Huh? Yeah, very clear. This is 2 to the power 0. This is 2 to the power 1. This is 2 to the power 2. This is 2 to the power 5. So I can write it summation I equal, yeah, I can make it 1 or 0, who cares? 0 to 5, 2 to the power I. To the power 0 plus 2 to the power 1 plus 2 to the power 2 up to 2 to the power 5. Okay, this one. 19. X plus x squared plus x cubed plus x to the power n. I'll try the summation. Need to be careful here. Yeah, it's the power things. Huh? So x to the power I, where I starting from where? From 1 up to n. So I have x to the power 1 plus x to the power 2 I equal 2 plus x to the power 3 I3 and so on up to n. Okay. Now I have this sum. 2 to the power 3 plus 3 to the power 3. Huh? Example. 2 to the power 3 plus 3 to the power 3 plus n to the power 3. Am I right? Yes. Same idea, but now starting from where? I equal 2 to n. And that will be I cubed. 2 to the power cube plus 3 to the power cube plus n to the power cube. Assume he asked me, I wanted to start from 1. I want it from 1. So if you want to write it from 1, it means I want to start with 2. So this is I can write it I plus 1 to the power 3. So my starting point is 2. My last one is not n. It will be n minus 1. So when I substitute it, I'm getting n. So instead of 2 to the power n, I can make it 1 to the power n minus 1. It's the same one. Also, I changed the ith. Sorry, something for something, something or something. Okay. Yeah. Oops. Yeah. This is some of these formulas. The summation of 1 I equal 1 to n will be n. Why is that? Since I add 1 plus 1 plus 1 n times. So that give me n. Summation of I, which is 1 plus 2 plus 3, that will be 1 plus 2 plus 3 plus n. That I have this formula, n times n plus 1 over 2. I square, it will be n times n plus 1 to n plus 1 over 6. I cubed is similar to the I, but to the power 2. Also, if there is a constant, you can deal with it like the one, because that will be c plus c plus c n times. So it's n times c. Also, if you have c with the I term, I can take the c outside. Sum, you can distribute it. Difference, also you can distribute it. Product, you cannot. Okay, let me now do some of these. And I need to find the value of the sum. Okay. Yeah, some of them is easy ones, some of them you need these formulas. Okay, so 21. I think I left the space here. Yeah, 21. Summation of this, I equal 4. That will be what? 3 times 4, 12 minus 2. Let me rewrite it since I have a space. That will be 12 minus 2. That will be 10. I equal 5. 3 times 5, 15 minus 2. That will be 13. I equal 6. That will be 18 minus 2, 16. I equal 7. 21 minus 2. That will be 19. I equal 8, which is the last one. 24 minus 2. That will be 22. So what will be the total? Yeah. This will be 35. Correct. And this is also 35. 30, 70, 10, 80. Okay, 23. Summation j equal 1 to 6. 3 to the power j plus 1. I'm doing many problems just to be sure you know, we understand it. 3 square j equal 1, 1 plus 1, plus 3 cubed, plus 3 to the power 4, plus 3 to the power 7, plus 3 to the power 5, plus 3 to the power 6, plus 3. I think you can do it. 25, I think we did something similar. Minus 1 to the power n. 1, it will be minus 1. 2, it will be plus 1. Minus 1 plus 1, 4. I have even 1. It means I will stop at 1. Minus 1 plus 1. So the answer will be 0. 27. Summation I equal 0, I think. 0 to 4, 2 to the power I plus I square. When I equals 0, I have 2 to the power 0. That will be 1 plus 0. When I equal 1, that will be 2, 1 square, which is 1. When I equal 2, that will be 4 plus 4. When I equal 3, 2 to the power 3, which is 8, plus 3 square, which is 9. When I equal 4, have 2 to the power 4 is 16, plus 4 to the power 2, which is also 16. So the answer is 1 plus 2 plus 8 plus 17 plus 16. So that will be 10, 17 plus 7, 34 plus 10, 44. Okay. Now it comes to the problem where I need these formulas. Okay, 29. Summation I equal 1 to n to I. Okay, I can take the 2 outside. Since I have this condition, I have the constant, I can take it outside. I leave the argument with the I. Summation I equal 1 to n of I, which is this one. Ready? Yes. So that will be 2 times n plus 1 over 2. 2 cancel, so I have n square plus n. That will be n square plus n. 31. 31. Summation I equal 1 to n. Summation I equal 1 to n. I square plus 3i plus 4. We notice in no, I can distribute the sum. Can use this. That will be what? Summation I equal 1 to n of I square. 3 I can't get outside right away. I have summation of 4. Okay. I square, I have this formula. I have this formula for I square. Let me just rewrite it. n plus 1 times 2n plus 1 over 6. I have this formula n plus 1 over 2. Summation of 4 with summation of c. There is no I. So it will be n times c. So I have plus 4n. I can make a common denominator. What you will get? N times n plus 1, that will be n square plus n. Okay. That will be n square plus n times 2n plus 1. Let me some space. Because I will do it at the same time. I have what? 2n cubed. I have 2n square plus n square plus 3n square plus n. This is this one. Now this is 2 multiplied by 3. So I have plus 9n square. But this is n square plus n plus 9n. This one over 1 is multiplied by 6 plus 24n. So the answer will be what? 2n cubed, 3n square, or 9n square. That give me what? 12n square. I have n, 9n, 24, 10 plus 34n over 6. I can take 2 common factor. So I have n cubed plus 6n square plus 17n over 3. That would be my answer. We did this, we did this. Now let me do this one. Summation I equal to 1 plus 1 to n of I plus 1 times I plus 2. Summation I equal 1 to n I plus 1 times I plus 2. What was the problem? 33. 33. That will be what? Summation. First, I will do the calculation. I square plus 3i plus 2. Then I just distribute the summation. I square plus 3, like what we did before, of I plus summation of 2. Yeah, it is almost the same as this one, but instead of 4, I have 2. So I have n plus 1 times 2n plus 1 over 6. This is 3, n plus 1 over 2, and this will be plus 2n. So that gives me over 6. We did it 2n cubed plus 3n square plus n. Huh? Is it? Yeah, plus n. That means I have multiplied by 3 plus 9 n square plus 9n. Yeah, this one over 1, that will be plus 12n. So the answer is 2n cubed. Have 3 n square. This is plus 12n square. This is 10 plus, so that will be 22n over 6. Take 2. In fact, have n cubed plus 6n square plus 11n over 3. Okay, the last one. Summation I equal 1 to n I cubed minus I minus 2. The number 35. Oops. 35. Summation I equal 1 to n I cubed minus I minus 2. Is it? I cubed minus I minus 2. Yes. Okay. Do the calculation. That will be summation I equal to n of I cubed plus minus, not a plus. Summation I equal 1 to n of I minus summation I equal to n to 2. Okay. I cubed, they have the formula. This is the formula for the I cubed. I'll use the formula, which is what? n plus 1 over 2 all square minus, this is n plus 1 over 2. This is minus 2n. Okay, so I have what? N square times n plus 1 all square, which is n square plus 2n plus 1 over 4 minus n square plus n over 2 minus 2n. Common factor, common denominator, 4. So I have n to the power 4 plus 2n cubed plus n square. 4 means multiplied by 2 minus 2n square minus 2n minus 8n. So the answer will be over 4 n to the power 4 plus 2n cubed. I have n square minus n square minus 10n over. So that will be my answer. So it's just a matter of calculation. Okay. Sometimes it's not only doing calculation with the limit, with the summation. Also, I need to do what? The limit. And this is the form which we will use when we do the area. Okay, but let us do the limit with the summation. So 43, I need to do the limit of this summation. Notice this 1 over n does not depend on I. So I can take it out. It's 1 over, I need the limit, don't forget the limit. So I take 1 over n outside, I have summation, I equal 1 to n, I square over n square. Also the same thing, n square, I can take it outside. That will be limit and goes to infinity, because n square does not depend on I. It will be 1 over n cubed, summation, I equal 1 to n of I square. I square, I know the formula for that. That will be limit n goes to infinity, 1 over n cubed. That will be what? This summation. It's n plus 1 times 2n plus 1. Which is this formula. I'm using this formula. over 6. So if we do the calculation, that will be limit n goes to infinity. What is it? Yeah. N goes to infinity. I have in the numerator 2n cubed plus 3n squared plus n over 6n cubed. This is the same degree. So just to find the limit as it goes to infinity, just take the coefficient. That will be 2 over 6, which is 1 over 3. Okay, now let me do the second one, 45. There's space. Yeah. 45, that will be summation. I equal 1 to n. 2 over n, I can take it out. Doesn't depend on I. Inside, I have what? 8i cubed over n cubed plus 5 plus 10i over 10. 10i over n. So that give me what? 2 over n. This summation, I can take 8 over n cubed. Don't forget the limit. Let me do that. Let me do the substitution, then I will deal with the limit. I write the limit at the end. So I'm doing only these things, the summation. Okay. So that give me what? 2 over n. Okay. Here I have what? I can take 8 over n cubed outside, and the summation I equal 1 to n of I cubed plus 10 over n times the summation of I, where I equal 1 to n. Okay. So that give me what? 2 over n, 8 over n cubed. This one is what? n plus 1 over 2 all square. Okay. And this one, 10 over n plus 1 over 2. Do the calculation now. 2 over n outside. What will be inside? I have 8. That will be n squared times n squared plus 2n plus 1, which is n plus 1 all square, over 2n cube. Actually, I can cancel 2. No, this is over 4. Don't rush it. Over n cube, 4n cubed. Okay, don't rush it. Plus, this is 5 n squared plus 5n over n. Correct? Yeah, n squared plus n, 10. Yeah, this is, I can cancel. 5, this is cancelled. 5n squared plus 5n over n. Now I can take 2 over n. What is the common factor? Will be 4 cubed. What I have here? I have 8 n to the power 4 plus 16 n cubed plus 8 n squared. There, I multiply by 4 n squared with this one. 4 n squared. So I have plus 4 n squared times this. I'm doing it in calculation mode to be sure. So my answer will be 2 over n. Downstairs, I have 4 n cubed. 4 n cubed. In the numerator, I have 8 n cubed, 8 n to the power 4 plus 16 n cubed plus 8 n squared. Now multiplying 4 n squared with this plus 20 n to the power 4. I have plus 20 n cubed. And that will be what? I have 16. I have this plus this, 28 times 2, that will be 56. Okay. N to the power 4. I have 16 n cubed plus 20 n. Actually, 2, I can cancel it. Yeah, this will be 2. No need to multiply by 2. That will make it easier. That will be 28 n to the power 4. I have 16 plus 20 plus 36 n cubed plus 8 n square over 2n to the power 4. Okay, now when it comes to the limit of this, no need to worry, just the highest coefficients. It's the same degree. That would be 28 over 2, which is 40. So this is my answer. Okay, let me do more problems. Evaluate this one. The main idea in this part is to deal with the sigma notation. To be sure I have the sigma notation. Yeah, I'm almost in the middle. Let me do this one. Yeah. And those are the old exams. And then we have the questions from the book. Okay, let me do this one. That will be what? Summation I equal 1 to n. 4i cubed minus 3i. Do the formula. That will be summation I equal 1 to n. I have 4 times I cubed minus 3 summation y equal 1 to n of I. That give me what? 4 times n plus 1 over 2 all square. And this is n plus 1 over 2. So that give me what? N square times n plus 1 square. Since this is 4, cancelled with 4. Minus 3 over 2 n square minus 3 over 2 n. So that give me what? N square times n plus 1 square, which is n square plus 2n plus 1 minus 3 over 2 n square minus 3 over 2n. So I have n to the power 4 plus 2n cubed n square minus 3 over 2 n square, which is minus half n square minus 3 over 2n. That will be the answer. Find the summation of 1. Also, we know it will be n. Huh? No need to worry about it. I want to do this for different n's. So first, I need to simplify this instead of substituting. I can do this summation I equal 1 to n. Let me do it here so we have space. Summation I equal 1 to n. I have I plus 1 over n square. This n square, I can take it out. Summation I equal 1 to n of I plus 1. So it will be 1 over n square. This summation plus this summation. That give me what? 1 over n square. This is, I know it, n plus 1 over 2 plus n. So my answer is 1 over n square. That will be what? N square plus n over 2 plus 2n over 2. Just simplify the calculation. That will be 1 over n square, 2n square. Yeah, I can finalize it. That will be 2n square. Numerator will be what? N square plus 3n. Now I can simplify, substitute easily. N equal 10. It means what? I have 10 square plus 30 over 2 10 square, which is 130 over 200. Let me do n equal 100. Do it the same. 100 square. The result plus 3 times 100, which is 300 over 2 100 square. 100 square, it means 0 0 0 0 plus 300 over Same thing with times 2. So you can simplify this. It will be 30 over 20. Huh? This one will be what? Yeah. 300 is there. That will be 10, 300 over this. Can cancel this. That will be 1 over 3 over 200. I will leave the rest for you. These things I think you can do. Matter of calculation. Limit n goes to infinity of this one. We'll do the calculation. Don't forget the limit. 3 over n, I can take it out. Summation, I equal 1 to n. I square over n square plus 1. So that will be limit. N goes to infinity. 3 over n. What is that? It's 1 over n square. Summation of n square, which is n plus 1 to n plus 1 over 6. This is this, huh? It took 1 over n square outside times the summation of I square. Summation of 1, it's just n. Okay. Now we need to simplify it. The limit n goes to infinity. 3 over n. What do you have here? Yeah, this one we did before. It was what? 2n cubed plus 3n square. Yeah. Plus n over 6n square. Plus n. Or I can simplify it more. Limit n goes to infinity. 3 over n of what? 2n cubed plus 3n squared plus n plus 6n cubed over 6n squared. Plus, that will be what? I have this with this, 8. Yeah, the 3 can cancel it, huh? This will be 2. That will be 8n cubed plus 3n squared. Don't forget the limit. Don't forget the limit. Yeah, limit n goes to infinity. 8n cubed plus 3n squared plus n over 2n cubed. Same degree, that give me 8 over 2, which is 4. That will be all the exams. Let me do all the exams. Yeah. Okay. 2 over n to the power 4, 1 plus 8 plus 27 plus n cube. I need to rewrite this in terms of summation. That will be limit n goes to infinity. 2 over n to the power 4. What is this? This is 1 cubed. This is 2 cubed. This is 3 cubed. So this is summation. I equal 1 to n of I cubed. Yeah, which is 1 cube plus 2 cube plus 3 cubed and so on up to n. So this will be limit n goes to infinity 2 over n to the power 4 times. I know this formula. It's n plus 1. Let me write square over 4, which is, I can simplify it. 2 over n. And cancel this. That will be 2 to save time. That will be 1 over n to the power 4. What I have here? I have n square times n square plus 2n plus 1 over 2. So I have limit n goes to infinity, n to the power 4 plus 2n cubed plus n square over 2 n to the power 4. Same degree, so I have 1 over 2, which is this. Okay. Summation of I square where I is running from 1 to 50. I know this formula. It will be, yeah, I know the formula. I equal 1 to n of I square. It will be n plus 1 to n plus 1. Don't forget over 6. Now I'll choose n equal 50. So that will be 50. N plus 1, 50 plus 1, 51. 2 times 50, 100 plus 1, 101 over 6. Okay. Now, Yeah, I know 51 or 51 is 3 times 17, huh? 51 is 3 times 17. So this is will be 17 and this is will be 3. 50. No, I divide by 3, so that will be 2. This is cancelled also. I have this one 25. So I need to multiply 25 times 17 times 101. Oh, 25 times 17 give you what? Can I do it quickly? Yeah, this one I can do it quickly. Let me do this one. 17 times 5 is 53. 14, 17, 25, 5, 2, 4. 425. So that will be 425 times 101. I can do this trick, 425 times 100 plus 1, which is 42500 plus 425. 25 times 17, 53. 7 to 14 plus 3, 17, 25, 5 to 4, 425. I need to multiply it by 101, huh? 2 times 50, 100 plus 1, in a 50 plus 1, 51, in a 50, times 101 over 6. By 2, this is 25. Or 2, 425 times 101. It will be, yes. Plus 425. That give me what? 42925. Yes. Just do the calculation. This is 5 plus 0, 2, 9, 2. That will be my answer. I want to do this summation, see what will happen. First, I will take 1 over n square outside, since it's not related. 8i plus 3. So that will be 1 over n square. I have what? 8 summation of I plus summation of 3, since I can distribute the summation. So that will be 1 over n square, 8 n plus 1 over 2 plus 3n. That give me what? This is 4, this is 1. I have, here I have what? 4. 4n square plus 4n over n square plus 3n over n square. So that will be 4n square over n square plus 4n over n square plus 3n over n square. So that give me 4. This is 7n over n square or 7 over n. Which is this one? Okay. This summation, same idea. I'll take 1 over n to the power 4 outside. That will be summation. I equal 1 to n, 2i cubed minus 3i. I will use this at the end. Huh? Let me do the calculation. Then I will add or subtract or add these things. That will be what? 1 over n to the power 4. I can take 2 outside. I cubed minus 3 summation of I. Okay, that will be 1 over n to the power 4. Okay, I have what here? 2. I have n square plus 2n plus 1, which is m over 4. minus 3 n plus 1 over 2. I want to do the calculation quickly. 1 over n to the power 4. This is 1, this is 2. I have here what? N to the power 4 plus 2n cubed plus n squared over 2 minus 3n squared plus 3n over 2. Sum them. N to the power 4. What you have? N to the power 4 plus 2n cubed minus 2n squared, huh? Since I have what? N squared minus 3n squared minus 3n over 2. So that will be what? I have n to the power 4. Now I'll distribute, or I can make this n to the power 4. So simplified, that will be half plus 1 over n, okay, minus 1 over n squared, okay, 3n over this minus 3 over 2 n minus 3 over 2n cubed. Then I add this minus 1 over n plus 1 over n squared plus 3 over 2n cubed. Had it cancelled. This is cancelled. This is cancelled. So I'm getting half. So this is my answer. Okay. Use the summation formula for n equal 10. Find this. Simplify it first. I can take 1 over n cubed outside. Actually, I can take 6 over n cubed outside. What is the summation? It's k squared minus k. Now use the formulas. So I have 6 over n cubed times what? Summation of k squared, which is n plus 1 to n plus 1 over 6. Okay. Summation of k, which is n plus 1 over 2. That give me what? 6 with 6 cancelled. This I think we did before. It will be 2n cubed plus 3n squared plus n over n cubed minus n plus 1 over 2. Not n plus 1 over 2. No. Multiply by 6. So I have minus 3 n squared plus 3n over n cubed. Right? Yeah, I have 6. This is 3 times n squared plus n, 3n squared plus 3n over n. Calculation, instead of calculation. This I can simplify it. 2n cubed, 3n squared minus 3n squared gone, n minus 3n minus 2n over n cubed. Or it is 2 minus 2 over n squared. Yeah. Now if n equal 10, that one will be what? The sum will be 2 minus 2 over 100, which is 2 minus 0.02, which is 1.98. I think this is easy one from the book. Yeah, I think I will leave it. Yeah, this is the one which we just did. The rest is just calculations. You need to simplify this and do it with 16. You know what? Let me, since this is the remaining, let me do it. I equal 1 to 6, 3i plus 2. Find the sum by adding each term. Yeah, I equal 1. It will be 5. I equal 2. 8. 3 times 2 plus 2. That will be 11. I equal 4 will be 14. I equal 5 will be 17. I equal 6, it will be 20. I will leave it for you to do the calculation. Equal something. This one, easy one. 1 plus 1 over 2. K equal 1. K equal 2. It will be 1 over 5. K equal 3. It will be 1 over 10. 3 squared plus 1. K equal 4. It will be 1 over 17. Then you can do the calculation. I will leave it. Now you want sigma notation to write the sum. I want now to take it to make it a sigma notation. Notice for example, 12, these are fixed. These numbers are fixed. So my summation will be 6 over 2 plus something. And I have this is 1, 2, 3, up to 11. So where I is running from 1 to 11. That's it. Here you have what? You have summation. You have 2 over n. This is not related to I. And it's going 2 times 1. Here 2 times 2, 2 times 3, and 2 times n. Same thing here, 2 times 1. So that give me what? Summation I equal 1 to n, where I have 2I over n cubed minus 2I over n. All of this times 2 over n. Check it. I equal 1. I have 2 over n cubed minus 2 over n times 2 over n. I equal n, the last one. It will be 2n over n cubed minus 2n over n total. And I equal 1 to n. I think this one, you can first simplify it. It will be, yeah, do it for I equal n. I have summation y equal 1 to n, 5I minus 4. That gives me what? 5. Summation of I, which is n plus 1 over 2 minus 4. Now choose I equal 16. So of what? 16. So an I equal 16, huh? I equal 1 to 16. That will be 5 times 16 times 17 over 2 minus 4. This is 8. Yeah, I think I will leave it for you. And this one is, first you need to simplify it. That will be I square plus 6I plus 9, which is summation, I equal 1 to 7, I cubed plus 6I square plus 9I. I'm doing it for n. Huh? First, let me do it for n. I think you can complete it. This one with it. Yeah, I think I will stop here. Let me stop the recording. Yeah. Stop the recording.